Hi, welcome to video 8. In this video, we will learn Introduction to Exception and various exception types, exception handling, using try-catch block, using multiple catch blocks, using nested try block, using try-catch finally block, writing Java program with exception handling, using try, throw, catch, finally block, creating a user-defined exception or custom exception. But apart from that, let's get started. One more discussion, which is called as exceptions. Exceptions. A quick understanding of exception and the need of it. So let's try doing it. So I want to have the introduction to what is called as exceptions. I'm sure that we haven't seen any exceptions as such, except for a couple of times when we did encapsulation, right? But anyways, let's understand how these exceptions will work and why we need exceptions. The whole idea of having exception is to deal with something like this. Imagine if I have a value which is constant and if I try dividing by zero, there's no meaning for it because this will invariably abruptly stop in our system. That's the whole idea. If I try taking int, if I have an array which is of int arr is equal to new int of 4, and if I say arr of 2 is equal to 33, this is perfectly fine. Arr of 3 is equal to 44, this is perfectly fine. Arr of 4 is equal to 55, this does not work because since the number of elements which you have got is 4, the array index starts from 0 and up to 3. Now this will give you some exception. What kind of exception they give? They give some exception. This is just an exception as of now. Let's not worry about specific. It's an exception, right? There's a first scenario, there's a second scenario. There's a third scenario. I can have an array perfectly fine. So if you see the way how arrays are getting constructed, they just need an integer. Can I give something called as -4? Now, logically thinking, this is wrong. How can an operating system allocate a memory for negative integer? That's not possible. Right. This third scenario where I have to throw some exception or I have to exit my program gracefully. It's just not like exiting, but we want to always make sure the program gets exited gracefully, giving some meaningful message for the end user. That's the whole idea of having. Likewise, if I have one more scenario where you have a Java, on the other end you have the file, or you have Java, which we are working. On the other end, you have somebody called as database. If there is a communication problem between these two people, whom to blame it? Now, this is something which we have to figure out. There will be IO exception, there will be a SQL exception. Now, the whole idea here is there could be an exception. If there is a network breakdown between the file and the application or a database or ERP system or some other system, there's a network breakdown, the Java has to be intimated. The Java has to intimate the end user or developer saying that, hey, look at this. We had this problem, this, and it has to be resolved in this. This is where we try having something called as exception. Exceptions are not the normal flow of work. They are something which happens without our knowledge. We don't expect at runtime. That is where the whole idea of exceptions will come into picture. On the verge of exceptions, we have two broad categories. Exception are classified into two broad categories. The first one is called as unchecked exception. The second guy is called as checked exception. Now, unchecked exceptions are those exceptions which can be handled by JVM. You call it whatever or Java, right? So here are those exceptions which has to be handled by developer or user. What do you say, right? So unchecked exceptions they have some meaning, right? We'll try knowing it. But as of now, try knowing it. Unhandled, unchecked exception, meaning Java can do something or it can help me something. But when it says something as checked exception, Java does not come into picture. Java says that, boss, I cannot understand something. Okay, just to give a little heads up. For example, if I have a value which is 10 divided by 0, this is pretty common problem for all of us. Maybe if you go to a programming language called C, C++, Java, or .NET, Python, PHP, Ruby, anybody for that matter, all these people have a common problem. This is all handled by Java. They fall into category of unchecked exception. For example, if I want to connect from Java to database, if something goes wrong, who's responsible? Can you go ahead and blame Java, saying that, hey, look at this Java, my MySQL is down. Can you help me? No, Java says, I don't know if uh, what do I do when MySQL goes down. They fall into category of checked exception, right? So this is what we're gonna do for next couple of days, where even with the JDBC, even with the IO, just to give an heads up of exception. Even in the threads when we go over, we'll have an exception when you want to stop an exception, right? And so on. That's a whole idea of building an exception. Let us go understand in little detail of the need of exception and how it can benefit us for programmatically. Right? Let us get started, understand some basics of exception. So just a quick heads up on the super most class in our Java, we know this guy object sits. So we'll keep this object as it is. A child of object, the immediate child of object, we have somebody, and this guy is called as throwable. Throwable. That's my class. The throwable has got two children. The first child is called as error. Error. The next guy who's called as exception. Exception. Okay. The error as in a class, we are not concentrating much. I believe that everybody have done error on the verge of executing. What is this? Like missing semicolon. The curly braces are not closed properly. The parentheses are not closed properly. All the syntactical people are handled here. Our discussion is not pretty much here. We're not going to discuss it. So anything you miss it in your program is an error. But the whole idea here will deviate to somebody called as exception. When it comes to exception, we have two broad categories. We have two broad categories, the first and the second one. The first category, as we have heard, these are called as unchecked exception. Unchecked, this is called as checked. This is here, CHC, checked exception. Makes sense? On the unchecked exception are those exceptions which get inherited from another Java given class. A lot of classes from unchecked exceptions are Java given itself. We are not touching it. But if you want to be part of the unchecked exception, then they cannot be child of exception directly. They should be a child of another class, which is called as runtime exception, who are called as runtime exception. Anybody who's child of a runtime exception, they are eligible to become unchecked exception. Hope this makes sense. Who are those people who who fall into this category? So the whole idea of these people who fall into the category are here. One is arithmetic exception. Arithmetic exception. So where does arithmetic exception come into picture when you try dividing 10 by 0? Or we can we can override this behavior to check our own business logic. All right. So something like salary should be less than this, salary should be greater than this. I don't know. We remember that the first example which we did with encapsulation, where we had an opportunity to check if the salary is less than 5,000. We give a message in the setter and set the value as 5,000. Right. In such case, we can throw an exception or something called as uh, array index out of bounds. Array index out of bounds. Where will this come? So if you have an array of size 4 and if you are storing on 10th position. So in such case, you will have array index out of bounds exception, or format for that matter, number format exception. Number, number, format, exception. Why it is? We remember that command line argument which we had. Command line argument. If I put 10, if I can convert this as integer at percent of 10, that is congratulations. That's perfectly fine. But if I put 10a, this converting into number format exception will throw an exception because 10a cannot be converted as integer. Likewise, you have like various people like negative array sized exception. You cannot instantiate array with negative and so on, right? On the other side, on the checked exception, these people are something not completely to do with Java, to do with other party. Who are these people? One is IO exception, one is SQL exception. There could be somebody called as clone, not supported exception, and so on. There are like a lot of people out there in the uh, checked exception. So now what we do is to get started, we will have the story of unchecked exception and see how things go well. Then we'll go with checked exception and see how things go well here. Class, let's create a class. I say this is exception, example, example 01. Perfectly fine. So here, let's have the main method. Let's have the main method. So not to write an exception, let's create a simplest example. I will say there is an integer number one. Okay. So we'll just call it as 10. Integer number two is equal to 2. So here, what we do is we will have somebody who is called as uh, int result is equal to number 1 divided by number. And also system.out.println result is result. Perfectly fine. So let's go ahead, click on play. It works well. Oh, great. It says result is fine. No problem. Plus, I want to put one more statement here. I just want to put one more statement as a system.out.println. Other business logic goes here. So I click on play. Oh, no problem. So it still gives a result, and other business logic is kept here. Now we may have to assume ourselves that the values will not be hard coded. The values will be taken by end user in some means. This can come from some file or command line argument, or something will be done, right? Which we gonna take it in some time. We can use scanners, we can use IO, and so on. But now, for some reason, imagine user has given a value called as zero as a denominator. So what should happen by dividing 10 by 0? So when I click on play, what would have happened in the story is something like this. So it says that exception in main java.lang arithmetic exception has occurred, and there is a nice message which says, oh, you tried dividing by 0. At which line? At line number 9. In where at com estate 7, estate day 7, exception example 1, in the method called as main at this line. Let's click on this. It'll take you to the class. Oh, here I had a problem. So now, since I have a problem, this should not be executing. Invariably, what happens at this line, Java will invoke OS to stop the application, or we call it abort. Abort. Abort is stop the application immediately. No more statements will work. So these statements will not work. I'm okay if this statement does not work because you're trying to print result. But what is wrong with this statement? What is wrong with this? This is perfectly fine. This is just some other business logic. It has nothing to do with these people, right? So this is where we have to come across. When we say something called as exceptions, exceptions are something which occur. Now, there are some nice ways where we have to handle the exception. Now, how do we handle the exception? All our exceptions in the world are handled in some special block. Now, what is this block called as? This block is called as try block. So, what I do is I put this block called as try block, which meaning try to execute some business logic. So, all your business logics will be executed. So once you execute this try block, there might be some possibility that as a developer, me and you can think saying that there might be possibility that the code written inside the try block may throw an exception. I'm not saying it will throw. I'm trying to say that may throw. For example, this code is perfectly fine when until and unless you don't have this value zero. If you have any positive integer, they work perfectly fine. But if I have zero, there might be possibility that they will throw an exception. Now the whole challenge of a developer like me and you is to understand that what kind of exceptions might come. So we know that if I try dividing it by zero, I might land up with an exception. What is my exception called as? The exception is called as arithmetic exception. You try, if you fail, there is a catcher. The catcher will wait for arithmetic exception. And every exception, when it is thrown from the JVM, that will give you a message which we can keep it in a variable. And for E, we can get information. We can from the E we can extract the information from here. Make sense? So this is where we can have somebody out there as a catcher who's a safe. The good thing about having try catch block is if you have a try and if this does not work, it will go to catch and you have some other business logic, right? Which is here. And the good thing is this person will still execute. Now, what your try block does is there is a problem. I'll give you a message, but I will not stop executing this. I will still have an opportunity of some other business logic working absolutely fine for me. That is where the beauty of Java will start shining now. Let's go ahead and try understanding how things can be sorted out. Here, I want to take this code. I want to take this code. I want to put a try block. I want to try put a try block till here. Till here, I'll have a catch. So here, the catch happens to be with one of the known exception which we have known. If you don't know, there's some other story behind it. We're going to talk about that a little later. So here, as of now, arithmetic exception, I use a variable called as E. So just want to print the object E so that it will invoke the toString of the class called as arithmetic exception. So let's go back and try doing it. So at the moment I click on play, it says that okay, java.lang that arithmetic exception you are trying to divide by zero, and the best part what happened is the other business logic goes here is still working, so that if there is some problem here, if there is a problem with this guy, they get caught here, and other business logic, that is where we say any application, when you try having it, they have to exit gracefully or give some meaningful message and keep moving further. They have to keep moving further. That's the whole idea of having it, right? The whole idea of having try catch block is to make sure the things are working well. Imagine for some reason, we tried writing some business logic. We made a lot of work as a developer. We sat together and did some brainstorm and came out with the catch block. But I don't know, over a course of time, in next couple of years, there may be an exception which might be thrown. I don't even know today. We are not guessing it, which might occur in the future, but we don't want our application to go for toss. Rather, we want our application to make sure to exit it gracefully. For that, for every problem to handle inside the try block, we can have another exception which is called as exception itself. Do you remember this exception class by itself is a supermost class in our hierarchy. So from our diagram here, which we have written here, if we see this exception in our whole story, the, the supermost guy happens to be the exception itself, right? So your IO exception, SQL exception, clone not supported, arithmetic exception, all those people are children of it. The supermost class is exception. If you have this guy handled, if you have this guy handled here, it means he this can handle anything and everything. Do you? This can handle anything and everything. And this guy who's called as arithmetic exception can handle what? Only arithmetic exception. Make sense? So let's go back here. I just want to introduce few more things for the same program. So if there is a value which is divided by zero, it will handle arithmetic exception. For whatever reason, I don't want to have number one as statically typed. I want to have um, from the end user. I'll say as a command line argument integer dot percent of arcs of zero. I hope we remember the statement. Percent of arcs of 1. So this will be arcs of 1. Perfectly fine. So what we do is we ask end user, hey, look at this end user. We have this program, we're dividing a number, but we want you to enter. So let's go ahead, try executing it. I'll right click. Now the problem starts. Now the problem starts. As a business logic, this program is perfectly fine. It's absolutely fine. But we never know what kind of exceptions might occur. So let's go back here to this guy, run configurations. When we put on run configurations under argument, I'll put a value called as 10 comma 0. This is fair enough. Apply, run. This will give you the output. Okay. Imagine for some reason, imagine for some reason in run configuration, user has not given or user has given 10, but he is given the denominator as A, the alphabet A. So I'll put apply and say run. Oh, what happened? It says that exception in thread main java.lang.perform an exception for input string A because you cannot convert A to integer. For that, you have to have another catch block, which is called as number format exception, as whatever Java has done, NFE. I'll say I can go ahead, try doing system.out.println of NFE, which is just a variable name, or I can say NFE dot print stack trace. Print stack trace, I oftenly use it in our discussion because as a developer, we just don't have to understand the message. We have to also understand. We should also understand uh, what is happening in the on the stack of invocation. That is where NF print stack trace will come into picture, right? We'll have NFE there or print stack trace there. All right. So let's go back and right click. So we have 10 and A. I say run. Oh, look at this number format exception. It gave the nice stack of information. The complete information is given, the line number. But what good thing happened is other business logic goes here. You are still able to see other business logic. Likewise, you might have a lot more things. For example, I will say right click, run as in configuration. We have passed two parameters, but unfortunately we have given value called as A. But imagine that user has not given the value of denominator at all. In such case, again it will throw an exception. But this time it throws an exception. My problem is not with this. My problem is some other business logic is not being executed. It means your program is aborting right there at line number 7 for us. But what we want is something else. We want some other business logic to work. For managing this, I can have another catch block, which is called as array index out of bounds exception. Let's say AIO EIOV, right? So that's a variable. Now, many times when you want to type it, I just follow certain convention, the array index out of bounds exception. So we should just put AIOVE in Eclipse and do control space. It will give you the auto-filled class name. AIOBE. All right. So here I'll say, I'll just put some message this time. Sorry, don't divide. Okay, sorry. Please pass the values. So I can say AI perfectly fine. So here also we just want to put some message so that we do some basic understanding. I'll say please pass only integers, right? So of course we also have got the string stack trace. So we'll give a nice separate so the user feels so he feels warm of seeing the output, right? So let's go back and try invoke it. I would want to give some alphabets. So 10A, apply, run. Oh, great. Look at this. Please pass only integers. And it has got a full story. It has got an exception. Please pass integers. All these things are pretty fine. So likewise, I'll go back. I will not pass any value now. Let's see how it goes. I'm not past A. There's no denominator value. I'll say apply and say run. Oh, sorry, please pass values. So what is the exception? This is the exception. If I give every value, if I give every value with 10 comma 3, this works perfectly fine. Oh, good. The result is 3. Other business logic goes here. This is fairly good. Hope this is making sense. Now imagine as me and you sit together, our project managers, team leaders, architects, all these people are developers. They sit each with a team and they decide to have the number of exceptions. So they say that okay, we wanted to have exceptions, but over a course of time, eventually there might be a possibility where I will land up in such a situation where I don't have a problem today, but I will surely have a problem future. For this, we can also have on the safer side. On the safer side, we can have a catch with exception. Exception. Now this guy is like a Superman. This guy can handle anything and everything. I'll say e dot print stack trace, and I just want to put some. I'm sorry, print stack trace. At the same time, I just want to put a message contact admin for correct with error message. Imagine that we don't have the clear idea today. Maybe next 5 years or next decade, there might be a possibility that we might land up something like this. In that case, this guy will be helping you. That is what I was trying to point out. So here, very important. At any point in time, this exception, which is the who's our Superman, has to be the last catch flaw in our story if I try putting this here before the specific exception, then you will have a compilation problem. Now, why it is compilation problem? Understand. When you have a try block, this guy can pretty much handle anything and everything in the world because he is the parent of all the exceptions. If he can handle, then what is the use of this guy? Is of no use. So make sure when you do it, it is always and always you will have the specific classes first, only then the generic class. On the verge of it, just to prove the point, I will cut this. I will cut this here and take it and paste it here. Look at this. From here to here, it works perfectly fine. One, two, three. All these three are giving it. Let's hover on top of this and try reading out the message, what they try saying it. It says unreachable catch block for arithmetic exception. It is already handled by a catch block for exception. So what we can do is we can remove that catch block. Replace catch with throws. Don't worry about it. We're gonna do it in some time, right? This is where we have to be a little intelligent and decide as how things has to be done. In similar fashion, let's assume that we want to invoke this. What could be the possibility? I'll say something like this. I will say, hey, look at this. I want to have an array, new integer of something like 4. This is perfectly fine. No problem. This is a valid statement. But can I say something called as -4? Can I say something like minus 4? The answer would be no. I cannot say anything like minus 4. In such case, let's go back, right click, run as application. Okay. So contact admin with errors. What is the problem? The problem is java.lang negative array sized exception. It means you tried initializing an array with the negative values. That's where the problem arises. We have landed up with a problem. This has invariably been caught. We just thought this in the future there might be a problem. Okay. Now let me just go back to one simple understanding. I have a if condition, right? So you will have condition. Can I have a if condition here? This is perfectly fine. I can also have else block here. I can have else block here. I can have if condition here, right? This is perfectly fine, right? Likewise, you can have nested if condition. It is also possible to have a nested try block. It is also possible to have nested try block. How does it matter and why is it required? Look at this. Let's assume that this business logic is more for arithmetic operation, and this guy who is initializing the array with negative is used for some purpose. But I don't want this guy to stop my execution because I did not have this opportunity to execute because I would have put this before. For this, I can get a try block here and a catch block here. Now, what could be the possible catch block here? Negative array size exception NAS. So here I'll say system.out. Sorry, please don't initialize array with negative values. Hope this makes sense. And maybe if you want some message, please go ahead and put that. Now that will be nice. NAS is the object value, right? So here, this part of the code will get executed. If this has an exception, this will be caught here, and rest of the business logic will still work. That's so good. So let's go back and execute run as application. Okay. It says that sorry, please don't initialize with negative value. It gave an exception. The program did not stop. It gave the result, and it is still exiting this part of the code with in such a way that it is exiting, but it is exiting gracefully. That's very important. Now, What happens when it comes to our writing business logic? You have a try block. The try block will execute. Eventually, that's the whole idea. The try block will execute. If not, the catch block will execute. Okay. Imagine yourself something like this. If you are trying to have a try block, right, where we do some database connection. So if you're okay, so let's put this way. So we want to do a program. Eventually, we're going to do it, which is with DB connection. All right. So in order to do DB connection, first and foremost, what we do is we'll open the connection, process with DB, then close connection. This is what we're gonna do. So let's assume that when we open the connection happens, process the database, the close connection happens. This is perfectly fine if things go in synchronous fashion. But certain times you open the connection, on the verge of processing, there might be a network breakdown. Once there is a network breakdown, they stop. Once they stop, a lot of connections get piled up. Imagine that we are based on out of a transaction-based application where like hundreds of connections are being made every second. So here, the processing with the database, the network breakdown will happen. They have to invariably caught in the catch block. So what we do is intelligently we'll try having a try block. We'll have a try block. Uh, we'll have a catch block. Catch block. So in the catch block, we'll have an exception. In the exception, we'll put some message to exit gracefully. Now, when I open the connection, if there is a problem, there's an error here, it goes to this guy. You open a connection, there is an error, this goes to exit, catch. Open a connection, process, there is an error, it goes to catch. Open a connection, process, there is an error, it goes to catch. This will be like a repeated number of times. If it happens like in a minute 500 times, imagine your database will get bombarded because you will have so many connections open. It is our responsibility to make sure that it is closed. Unfortunately, with this architecture, we'll not have an opportunity to invoke close, because what happens, the delegation would have happened from here. From this line, it gets delegated. So, in order to make the business logic work better, we have to ensure that this guy, anyways, will give a control here. This guy, who's called as close connection, will not get an opportunity to execute. How can I make this guy to execute? Eventually, whatever happens has to get an opportunity. For this, we have a specialized law which is called as finally. Finally, the final block will execute 100% immaterial. The try block has executed or catch block has executed. So what we do is we'll take this close connection and put it in the final block so that we know that this close will always work in your finally. So that's one block. So let's have a look at this. So I'll take this guy, I'll put this in another block and leave it here, right? In similar fashion, have a look at this. I'll go back to this guy. I will have finally, hey, I'm finally always here. This guy will execute. You do the smooth execution, you have it with the exception, whatever exception, he's still there. So let's go back and try and understand. Right click, run as application. Okay. The result is 3, perfectly fine. Hey, I'm always here. I'll right click, configuration, arguments. I'll make A so that it should give some exception. Great, there's an exception, but I'm finally always there, right? I'll go back, run as configurations. I would have no value passed for denominator, apply, run. Hey, I'm finally always here. Look at this. You do any possibility, the finally block is always there. This is one attached to try catch block or try block, which will ensure that some piece of the code will always get executed immaterial whatever happens. This is where most of our database collection connection close or file getting closed will happen, or any purging of database objects can be done in this place. This is a nice place. So as an architecture, we will have try, try, catch, final, or you can even have a nested try. That's perfectly fine. So let's imagine something where we have a method which is called public void check salary. So I'm just giving a simple example where user will have, okay, so instead of check salary, I'll say hike salary. So here, I'll say int new salary. So the whole idea here is I want to have to check if it is the given hike salary, I'm happy with that or not. So I'll just check if the salary hike is around $1,000, right? If new salary hike is greater than $1,000, I'm happy. So you say, okay, I'm good to work and I'm happy. So that's what I want to do. Else, if new salary hike is greater than 500 and new salary is less than 1000, no? For some reason we have got this salary. So what we want to do is we want to raise an exception. Else, if new salary is less than 500, in that case we want to have another exception. So hope this is making sense. So the whole idea here, we may have to understand not everything is part of the business logic. Now, when I say business logic, when you put something like system.out.println, they don't have the capacity to delegate. They're only good to showcase the value. But when I say something called as exception, I can capture this exception and give it the control to somebody else for execution. But the whole idea here, we have to be very intelligent now to understand what is business logic, what is an exception. The exception is something which is not a normal. For example, I say that there is an employee who gets a salary hike less than $500. In such case, he says that no, no, we don't. We just want to come out of the company. I have got a better option. Whatever, blah blah blah. So in such case, we may have to raise an exception. When you raise an exception, this control is given probably for finance team, admin team, project manager, and couple of other teams. So the whole idea is they will go through that, understand it, and try to resolve some problem. But if you have a salary hike rate greater than like $1,000, so people are okay. They are not delegating any uh, job to anybody. So that is where we have to differentiate between the new hike or a business logic or the exception, right? So let's take a simple example here to understand this much better and see how this goes. So I'll close this. I'll create a package. Let's create a package here in SRC. I call it day 8. I'll have a package which is called as com.sted.day8. So here, let's create a class. I'll say salary hike check. So I'll say sal hike check. That's our program. So what we do is first and foremost, I will have a main method. So that's where we want to invoke it. But I also want to have another method which is public starting void uh, check or check hike sal. I'll say int hike sal and string employee name. Employee. Now that's what we want to send it. Now I say, hey, look at this. If the hike sal got the hike this year, if this is greater than $1,000, we say, oh, hey, I'm okay and happy. Why? EMP name for the hike. So what is my hike? Which is hike sal. So hope this is okay. So let me put it on next line. So this is what your hike sal is. But now you say that, okay, else, if hike sal is greater than 500 and hike sal is less than equal to 1000, then there is a problem. So I say that, okay, now I want to raise an exception. Now the question is, what should be my exception? That's something which we have to discuss it. Else if hike sal is less than 500, I want to raise an exception. But the question is, what exception should I raise? So these are few scenarios where we have a business logic. As of now, we've just put like system.out.println. This could be any complicated code in the world. So that's absolutely fine. But the idea is this is part of the business logic. We have to differentiate if something goes wrong, I want to raise an exception. Now, we came across with a lot of people out there. One is called as arithmetic exception, number format exception, or negative array size exception, etc. etc. There are like so many people we were trying to talk. Now, these exceptions are just a class. If you try opening the story of JDK or Java API 7, so if you see these classes, they're just a class. So arithmetic exception is a class, but especially the extends from runtime exception. So let's consider for our understanding just a arithmetic exception. The good thing is if you have some business logic, if you try dividing it by zero, this is something which is delegated by Sun Microsystem or Java at the runtime. But now the question is, can I use arithmetic exception for my own business logic? The answer is yes. I can pretty much use this for my own business logic. For example, here uh, we have something like, okay, if I want to raise an exception, can I use, hey Naveen, can I use an arithmetic exception instead of we creating our own exception because we use it very rarely, just like for the sake of using it? The answer is yes. So let's go back to the documentation. Here I go to java.lang. That's where all the exceptions are kept. If you see, there are a list of interfaces, there are classes. Let me little scroll down. Here, you see there's a nice exceptions which these people have written it. Let me little zoom in. So here, I have arithmetic exception, array index out of bounds exception, array store exception, class cast exception, class not found exception, blah blah blah. Everybody are there. Let's click on one guy who's called arithmetic exception here. Under arithmetic exception, you see the story here. I believe this is what we have discussed it. Or the supermost place, the supermost class in the world for us is object class. The immediate child of object, there is somebody called as throwable. Now throwable has got two children. One is called as error, one is called as exception. Now the whole idea for us to discuss is on the exception. So what we do is we try checking exception. Exception has a child which is called as runtime exception. Then it has arithmetic exception. Now, the arithmetic exception is just a class. Since it's a class, if you just go back here and see the constructor, they have got two constructors out there. So they've got two constructors out there. One is default constructor, that's what which got invoked. By default, the message of the default constructor is number forward slash zero. That meaning we are trying to divide a number by zero. The next one, which is with the string, now there is an opportunity for us to pass the value which we need. So in order to do that, let's go back and check here. I say, hey, what exception to throw it? I'm gonna delete it. I'll say new. I'll just say throw. Just before that, I want to introduce you to one more guy. There are like few classes which gonna happen. So, okay, so let's put it this way. Let's put it this way. Very, very clearly. So what we did yesterday, this is something which we wanted to do yesterday. I'll say int result is equal to num1 divided by num2, assuming that int num1 is equal to 33, int num2 is equal to 0. In this case, now what happens? What happens? So this guy gets executed. So this is how it keeps executing it. When it executes, when it executes, it finds there is a problem in this line. So what JVM does, just comes to this line and tries executing. It says that the number cannot be divided by zero. What happens? Java by themselves has created something called as a ground. This is an exception ground. So what happens? There is something which I cannot execute. It just puts it in this ground. So this is all done by a class called as throwable. Throwable. What does your class called throwable do? The throwable class will throw anything which happens in the ecosystem. So now there should be somebody who should catch. Who will take care of all these things? It is all taken care by a class which is called as exception. Exception. Now exception is sole responsible for handling it. In addition to this, there are few specific things which we do it as arithmetic exception. So when I say arithmetic exception, JVM intelligently what it does is it will just check now, do I have somebody called as arithmetic exception which user has already handled it? If it is handled, then I will delegate the job to arithmetic exception. If not, Java can pretty much do everything by its own. You don't have to be interfered with it. But today, I want to have one more business logic where I want to give some message saying that, sorry, salary is very less or salary hike is less. So I want to give this. But how do I give it? I have to put it in this ground. In order to put it in this ground, I have to introduce you to another guy who's called throw. Now throw, what it does, it takes any object which is a child of throwable and throws it on a Java's playground, so that that message can be shown or you have an opportunity of exiting the program gracefully. So what kind of exception can be thrown? I can throw something called as new arithmetic exception, right? So I can pretty much try throwing arithmetic exception. Now, when I say something called as arithmetic exception, what happens? We are provoking JVM saying that look at this, I have an exception which is called as arithmetic exception, which I'm trying to throw it. What JVM internally does, it takes this class, it checks is this class a child of exception, or we call it in a simplest term is arithmetic exception is instance of exception. If it is true, then it puts it on your bucket or your playground. Then what you did, you just tried throwing it. So throwable class now is responsible to take the throwed object and put it in the Java's exception playground. So what we do is in similar lines, I'll say throw new arithmetic exception. But this time when I did control space, have a look at this. I will have two people. One is who does not take any parameter. The other guy is somebody who takes a parameter, which is a string. Likewise, there are many constructors which people have built, and do remember there is an opportunity for us to build our own exception in quite some time. We're gonna do it where we can define our. So now you ask me, hey Naveen, look at this. You're trying to say something called a salary hike, but what is arithmetic exception to do with salary hike? No, salary hike has nothing to do with arithmetic exception. I'm just trying to prove a point that it is possible in the world, right? So now I just take this guy, I'll say something like this. Hey, I'm not all happy with this salary hike, right? Of how much hike this person has got, uh, hike salary by who's this guy? Employee name. Makes sense. So here there might be another guy. I can go ahead and try using something called as um, arithmetic exception, or I can have throw new runtime exception. Perfectly fine. So here in runtime exception. So if you look at this runtime exception, this guy is little more. You have multiple constructors out there. So let's try throwing one of it, who is called string. I'll say sorry, I'm disappointed by salary. I'm just trying to put some message. The salary hike of hike sal by who's this guy? Employee. Perfect. So here we have the story. Now, very importantly, you have to understand, you just have to know one thing. Now, this program, how good it works, I don't know. It depends on the salary hike, what people will get it. If they get 2,000 salary hike, perfectly fine. If they get $100 salary hike, whatever. But the whole idea here is my program will still work for whatever business logic or whatever case you give it. And did you notice that there is no compile time problem? There is no compile time problem. All your unchecked exceptions can be thrown directly without surrounding that with a try catch block. They still work. They still perfectly work fine. So let's go ahead, try invoking it. I will say, hey, I want to have check uh, hike sal, hike sal of like 450, the employee name. Let's consider it as Harry, right? So I just put system.out.println, some other business logic goes here. That's what I want to say it. Now, what happens is I will have the salary hike because the control comes to me. So it invokes check hike sal. This guy will invariably call this method. When the invocation is made to this method, here it will check what is the value. Is it greater than 1000? No. Is it between this? It's lesser than this? Yes. It throws an exception. Since it throws an exception, it goes to arithmetic, I'm sorry, runtime exception in the playground. So it just shows a message, does its own job, and exits the program. That's very important. It exits, but at the same time, you will not have an opportunity of this guy executing. Let's click on play and try understanding it. I have made some mistake. All right, I missed a semicolon. Missed a So here, if you have a look at this, exception in thread main, sorry, I'm disappointed by salary hike of 450 by Harry. So if you just recall the discussion what we did yesterday, if it was number format exception, it used to give a message. If it was arithmetic exception, it used to give a message. Now it is possible for a developer like me and you to use an exception which people have already created and use with a customized message. That's a whole fun of it. And it will also give you the stack trace, saying that where the program started, it started at main and it goes up to check sal, then the actual story will begin, right? So now if I want to execute this part of the code, I can go back and put a right block and catch block. So I'll say first is arithmetic exception, AE. I'll say system.out.print. I just want to do this AE, not to give print stack trace. I'll say catch runtime exception RE. All right. So now let's go back and check how this will work. I'll click on play. Oh, great. Sorry, I'm disappointed by salary hike of 450 by Harry. Now, look at this. Some of the business logic is here. We ensure that if there is a business logic which throws something, and if I surround it with the try-catch block, the scope of that for this business logic will go here. The rest of the business logic still have an opportunity to execute it. That's very, very important. So now let's consider one more. Now, all those people who are there falls under unchecked exception. We know this unchecked exception. Now, why do they fall in unchecked exception? For a simple reason, they inherit from runtime exception. We have to be very clear in terms of understanding. There are so many exceptions which are called as checked exceptions, but these people are those who extend from exception class. Exception class. I hope we remember yesterday's discussion. What are those exceptions? One is called as IO exception. Now we just have to understand very clearly when will IO exception will occur. IO exception will occur in some scenarios where you try opening your file. Now, do you imagine by any logical sense if the file is not found, is it Java's problem? Java has nothing to do with if the file is not open. If the file does not present, if the file is in read-only mode, we cannot blame Java. So Java says there are few scenarios in the world I cannot handle at all. You have to handle by yourself. So the whole idea here, which I'm trying to say, is something like this. Imagine if you have a Java, which is your workflow, and you have a file system. So the file system is all about you keep your files, blah 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 files. So now, if I try opening the file, if the file is not available, can I go ahead and blame this guy? No. You have to make sure this entire scenario have to be handled by yourself. So in order to do this, there are few exceptions. One is IO exception, one is SQL exception, clone not supported exception, class cast exception. There are like so many exceptions out there for any of this guy. If you don't surround it with a try-catch block, even look at this, even with this, if you're not surrounding with this, it still works fine. But if I get rid of a runtime exception here for whatever reason, and if I have IO exception, IO exception for whatever reason, so IO exception. Now, do you see there is a little problem? There is a problem. You have, if you just hover it on this code, it gives you a nice red color underlined story out there. So they're all like underlined as red. So now it says mandatorily, since the kind of exception which you are trying to throw is IO exception, JVM says that, oh, I don't understand what it is. This is something which is out of my scope of understanding. What you got to do is you have to surround it with a try-catch block. It meaning if you have a code here, when you try throwing it, you should also surround it with a try-catch block. That's one goal. You have to surround it with a try-catch block. Or if you don't want to surround it, if you don't want to surround it, in such case, that's okay. The caller of this have to surround it with a try-catch block. That's mandatory. In order to do that, I will introduce another class here, which is called as throws. So there's a difference here. One is called as throw, which is a singular, throws, which is a plural form. When I say throws, meaning I indicate the caller of this method, stating that I might have a scenario where this method will throw the list of exceptions. So what here is IO exception. Perfectly fine. Look at this. My method is pretty happy. My method is pretty happy. But the problem is here. You see here, this guy has started troubling us with an red colored underline. It says that, okay, now what you did, I am invoking this method. When I invoke this method, this guy is throwing some exception, which is called a IO exception. And fortunately or unfortunately, this is a checked exception. Since it is checked exception, it is mandatory to make sure you have to surround it with a try-catch block. That is when Java compiler will successfully compile your Java code for execution. If not, Java compiler will not do any work because Java compiler knows that these are few exceptions which are not to be handled by Java, because that is very unclear, right? So what we do is we'll take this guy, surround it with try catch block. Now this is perfectly fine. So if you have a checked just to keeping it short, if you have a checked exception, you have to surround it with a try catch block here, or that method should have a throws clause. If that method has throws clause, then the caller should be surrounded with the try catch block because these are exceptions which are out of bounds for JVM to understand at the runtime. If I can use IO exception, the whole idea is, can I use my own exception? Can I use my own exception? Something like my company exception. So can I use my company exception? Let's put little more lights on this. So I don't want to use IO exception for whatever reason. So what I do is I'll go back to this Java Day 8 and create a new class just called as my company exception. So I just want to give some name, I'm giving it, but I ensure this is extends exception. So since I extend from exception, this class should or shall be eligible to have this or this. And this is part of checked exception. That is, you have to surround it with try catch, or if you are using throws clause, then caller has to uh, surround try-catch. Perfectly fine. So here, let's go ahead and construct our exception, which is like user-defined exception. So here, I want to make few things as it looks pretty similar to our arithmetic exception or runtime exception or anybody out there, right? So the whole idea here is I just want to have a string message, all right? So I want to have a couple of constructor. The first constructor happens to be public default constructor. I just put this dot message is equal to I don't get better string. I'll just say my company exception. This is something which you have to map in your mind. When you say arithmetic exception, you see that divide by zero, that is this, which is default constructor. So I'll have public string message. I just say this dot message is equal to message. All right. So this you can make sure you can have any message which you can. So any message which you send it, that will be stored. And I just want to show one more thing where you can go to source and override implement methods. And this class is called as exception class because we have inherited this from the exception class here. So here they come from the throwable. Here I'll have a lot of methods. So a couple of them, print stack trace, we can go ahead and override. Get message, we can override. So we can even have overridden a few methods like get localized method. So many times if we go with internationalization or localization, we can construct our own thing. But this needs a lot other things to be known, but we are skipping it. Here get message, let's override it. Maybe like toString is one from throwable. Or the toString, you can even take it from here. Right? Anything is good. So I want to take get message and toString. You can also make sure if you want to have print stack trace, if you want to give print string, we're going to come back to this. Whenever there is an exception happening, I want to keep this in a file or in a database. In such case, we can have our own print stream to be created. That's perfectly fine. But we'll just keep that on hold. I'll say okay here. So if you see here, I have a get message. I'll say get message is, I just want to put this dot message, this dot message. When you invoke message, I just want to give message. For toString, I would say return. Um, I would still have this dot message, but this time I just want to decorate it just to differentiate. I put a square bracket, square bracket, square bracket. So hope this should be okay. So it is possible for us to print it or have get message so that we are overriding the behavior. If you invoke something called as print stack trace, then it will call that will be calling super. Now which is super class happens to be exception class. Obviously, they'll give you the line number, the method where the invocation happens, the class name, package name, blah blah blah, all other details. Right. So now let's go back here. Here, instead of using IO exception, can I use my company exception? Let's see. I go back here and delete it. I just delete this. I just put that like throw new my company exception. Look at this. This is where the beauty of Java starts shining. You can go ahead, pretty much try doing whatever you want now. Your own exception. Now, this is what was happening in IO also. When we say IO exception, coincidentally, Java people have created. But the intention of creating IO exception from Java is not to deal with Java objects, is to deal with some external objects in the world. Something like my company exception. Now, when you say my company exception, what does your Java understand? Java is like in it does not understand what it is. My company exception is user have to give complete meaning for it. So here I'll say, sorry, I'm disappointed for hike of hike hikes. Yeah. Why? Who's that? Employee. Right. Perfectly fine. Good enough. Right, so I may have to put a semicolon. So now again the same old story where it is trying to have a red color underline. We can go ahead and try surrounding this with a try catch block or put the throws clause. So look at this. You put a throws clause of IO. It's still troubling me, but I can change it to my company exception. Since I make it like my company exception, the problem here is solved. You just have to understand when I say IO exception or my company exception, that is something which we're teaching Java. Oh, Java, look at this. You have to behave in this way when things go in this way, right? So here, the exception name, I just want to use this. All right. Great. So let's go back, click on play. Oh, great. So sorry, I'm disappointed for the hike of 450 by Harry. So who is doing it? It's all done by my company exception. Thank you for watching. See you in the next video.